This question asks, deep sea divers breathe a mixture of oxygen gas and helium gas. Typically, the cylinders are labeled 7 grams oxygen and 93 grams helium. If the container is pressurized to a pressure of 7.5 atmospheres, what is the partial pressure of each gas? The partial pressure equation is P, in this case of O2, is equal to chi of O2, that's mole fraction, times P total. And the mole fraction is the N of O2 multiplied by N total. Oops. So we know the total pressure, so P total is 7.5 atmospheres. So we need to figure out what the moles of O2 and the total moles are. So first, let's figure out the total or the number of moles for both oxygen and helium. So we have 7 grams of oxygen gas. And remember, oxygen gas is a diatomic, so it's O2, and that is 32.00 grams in 1 mole of O2. So when we plug that in our calculator, we get 0.219 moles of O2. And so that's going to be N of O2. And now for helium, we have 93.0 grams of helium. And the molar mass of helium is 4 grams, so 4.00 grams in 1 mole, because helium is a noble gas. And so when we plug this in our calculator, we get 23.3 moles. So N total is equal to 0.219 plus 23.3, and that equals 23.5 moles. So now we need to figure out the mole fraction. So for O2, chi of O2 is going to be 0.219 divided by 23.5, and that equals 0.00932. Now, you might be asking yourself, why does this value only have one place after the decimal when the number of moles of oxygen has 3? When we add numbers, the significant figure is tied to the one with the least number of digits after the decimal. So since 23.3 only has 1, we can use that there. When we go back to the small fraction calculation, we don't need to pair it back because we're dividing those two numbers. So the pressure of O2 is equal to 0.00932, and we are going to multiply that by the total pressure, which is 7.5 atmospheres, and that gives us 0.0699 atmospheres. So now we want to do the same thing except for helium. So I'm going to move this up a little bit. So chi of helium is 23.3 divided by 23.5, and that equals 0.991. And the pressure of helium is 0.991 multiplied by the total pressure, which is 7.50 atmospheres. And so I get 7.43 atmospheres. And those two together add up to pretty close to 7.5 atmospheres. So when we look at the partial pressure, we are able to calculate different components based on the mole fraction and the total pressure.